Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would start right away. Let me turn on my preview screen. Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we... Okay. Okay. So I am visible as well as equally audible. So let's start with yesterday's problem of the day. Today we would be doing yesterday's problem of the day. Okay. Thank you so much, Irudhva Swami. Thank you so much, Swami. Okay, so today we will be doing yesterday's problem of the day, that is maximum of minimum for every window size. Okay, this question appeared in Amazon, Microsoft, and one more company, and this is a hard level problem with a success percentage of 54%. Okay, so now let us move to the problem statement. Thank you so much, Priyanka ji. Okay, hi Swami, how are you? Okay, so we are given an integer array. Okay, the task is to find the maximum of the minimum of every window size in the array. So whenever, if you are a beginner and if you have a problem understanding the statement, what you should do is you should never look at this first. First look at what you need to tell. You need to first find out the minimum of every window size in the array. Minimum of every window size. So what is the minimum of every window size? I would tell you. Suppose we are considering the window size of 1. Suppose it is window size of 1. What are the window sizes of 1? Minimum of every window size of 1. So for first would be 10, then it would be 20, then it would be 30, then it would be 50, then it would be 10, then it would be 70, then it would be 30. This is minimum of every window. This is the window size of size 1. Then what is the minimum? Okay, for this would be the minimum, for this would be the minimum, for this would be the, as only one element is there. Okay, now you need to find out what? You need to find out the maximum among them. So what you should do is you should first read the second part of this statement and then you should read the first part. Then you would know the relation. Okay, that is the thing. Okay, so the thing is that what is the minimum of every window, and then you need to tell the maximum of that. What is the maximum of that? The maximum is 70. That's why for the first value the length is 70. Now let us take one more example so that we would understand this thing better. Okay. Okay. Now we would consider all the windows of size 2. Okay. First is 10 and 20. So let us write 10 and 20. Okay. Then 20 and 30. So let us write 20 and 30. Then 30 and 50. So let us write 30 and 50. Okay. Then let us write 50, 10. So 50 and then 10. Okay. Then 10 and 70. Okay. 10 and 70. Then 70 and 30. 70 and 30. Now let us find the minimum of every window size. This is what is given. What is the minimum here? The minimum is this one. The minimum 20, 30, minimum this one, minimum this one, minimum this one, minimum this one, and minimum this one. Now among all this minimum, which is the maximum value? The first value is 10, 20, 30, 10, 10, 30. So which is the maximum value? 30 is the maximum value. That is why for the length of size 2, the value is 30. This is why. Okay. Hey anonymous fan, how are you? मैं अच्छा हूँ. Okay, that is how you can consider the window of size 3. Okay, that is how you can consider. Now I won't be doing that because that would be a kind of waste of time and you won't develop the logic. So for the rest of the sizes, for 3 to 7, do it by yourself. I showed you the way for 1 and 2. Okay, now the rest would be homework so that you would also get the intuition behind it, how we are doing. First take out the value, sliding window. First take out all the values in each window. Then take out the minimum from each window and keep all those minimum side by side and take out the, from all the minimum, take out the maximum value. Okay, whatever this is. Okay, I'm audible till now. Okay, whatever the value that is, that would be your answer. Okay, now it is told that the answer varies from size 1 to the size of the array. Okay, how size 1 to size of the array? Size 1 we have already seen. Then we can consider window of size 2, then size 3, then size 4, then size 5, then size 6, and then size 7. Okay, this is why it is written that the window size would vary from 1 to size of the array. This is why, and the number of elements would be equal to the number of the answer. Okay, fair enough. Now how we would solve this problem? Okay, solving this problem, the most intuitive way I found out is, okay, the most intuitive way is that instead of seeing from what are the window sizes we can have the window sizes 1, 2, 3, 4, 5, 6 and 7. These are the window sizes. Now what we should do is we should start looking from the back, because if we start looking from the front now, it would be a little bit difficult, and if you see from the back, it would develop you a little bit logic. A logic would hit you. Okay, I would show you how it would be. Okay, I'm extremely sorry. Yeah. Okay. Okay. Okay, I would show you. So for the window of size 7, every element would be considered. So for every element, which is the smallest element is 10. So for window of size 10, the value would be 10. Yeah, the value is 10. For the window of size 6, what would be the value? The value would be either like this, either would be comprising of like this, or it would be comprising of like this. So either we can leave 10, either we can leave 10, either we can leave 30. Okay, so first let us look at this scenario. Taking this scenario, what would be the minimum? The minimum is 10, and taking this scenario also, this 10 is present in both the values. So the smallest value, that is 10, is there in both. Okay, both the considerations. Okay, so now 10 again. So we can see that the minimum element does matter. Minimum element does matter. So what can we do is, we are saying that after seeing this part, we need to check if this minimum element range is still what. We can know that minimum element range is still both, it is covering both the things. Then you can consider the length of 5. Then considering the length of 5, there are 3 options. Either you can take 1, 2, 3, 4 and 5, or you can take 1, 2, 3, 4 and 5, or you can take 1, 2, 3, 4 and 5. Then what is the thing that we are seeing? We are seeing that is 10 present in everywhere or not, and we can see that even if we leave this 10, this 10 would be present. That is why for this also 10 is there. So we can see that we need to see the range of the smallest value or the range of a value. So if this is stock, मुझे क्या देखना पड़ रहा है ना, मुझे देखना पड़ रहा है कि वो मिनिमम वैल्यू कितना दूर तक जा रहा है. दैट इज व्हाट वी वांट टू सी. सर इस स्टेप को रिपीट करना. ओके, या मैं बताता हूँ. सो क्या हो रहा है ना, अगर पीछे से करने लगोगे तो यू वुड सी कि जो मिनिमम वैल्यू है ना, उसको देख रहे हैं कि ये मिनिमम वैल्यू अभी भी हमारे अंदर है या बाहर चला गया. मिनिमम वैल्यू है, ये बाहर चला गया. ये मैनुअली करोगे तो इतना तो पता चल ही गया. तो अगर हम इसे दूसरा तरीका से बोलना चाहे तो अगर हम ये देखना चालू कर दे कि हर एलिमेंट को अगर हम उस वैल्यू को मिनिमम माने तो उसका रेंज कहाँ तक होगा. अगर उसका रेंज हमें पता चल जाएगा तो इट वुड बी द मिनिमम फॉर दिस थिंग. ओके, मैं बताता हूँ, ध्यान से देखना. ओके, सो वी कैन से दैट वी कैन सी द रेंज ऑफ ईच वैल्यू if we want to make it the minimum. So what I can do is I can take out a child from a class, and what I did is I tell him that all the students that are greater than this boy means in height, in terms of height, okay, get out from the class. So the person remaining, the person I have selected would be the maximum. ठीक है, ऐसे ये लॉजिक है. ओके, so we would do the same thing here also. Okay, so suppose for 10, for this 10, how far we can go? For this 10, this is the minimum for how far? This is the 10 minimum for whole of the array. So we can say that it is the minimum for the whole. Then the next thing is that for 20, we can see that it is the minimum till how much? Okay, we are standing at this 10. So we can see the minimum for how much? So this is max, this is greater, this is greater, this is greater, this is minimum. So this value. Then this side, this value. So 20 is minimum for the window of size 3. Okay, 20 is minimum for the window of size 3. Okay, then what we can do is we can take 30. 30, how far it can go? 30 can go till this side. Okay, this will not be the values, and this side, this is 20, so it is less, so this won't come to the values. So we can see that 30 is the minimum of window of size 2. So what is the thing is that, sorry to interrupt, I don't understand things in Hindi. Yeah, Swami, it is absolutely fine with us as well as for others. The thing is that sometimes, as the majority speaking people speak in Hindi, and some people connect better with Hindi, so when I explain the most crucial part, I repeat the same thing in Hindi so that it becomes comprehensive for each of the people. Okay, so I would be explaining for everything, but for the crucial part I would be explaining for Hindi also. If everyone is fine with English speaking all the way, then I am good. But what I think is that you would find Hindi a little bit more comprehensive, the people who speak Hindi, like the people from the people who come from parts of Bihar, like I myself come from Jharkhand. So English speaking culture is a little bit less here. That's why. Okay. So you would develop that culture while speaking, but for now we are considering both the cases. That is why I speak in both the languages. Okay. Okay. Fine enough. Okay. So we can see that 30 is the minimum of size 2. So now what do you mean by that? What do I mean by that? Siddharth, you showed us this thing, but what do I mean by this? Okay, I mean that we are getting eligible candidates. We are getting eligible candidates for each values. Okay, we are getting that. So ये बोलना चाह रहा है ना कि हमें एक वैल्यू मिल रही है. अगर वो कैंडिडेट जो लड़का को मैंने खड़ा किया था उससे बड़े वाले सबको निकाल दिया तो वो एक कैंडिडेट बन सकता है ना. I can consider him. So that is what we are doing. We are taking out the candidates and we are considering it for it. Okay? Like what I want to tell is, suppose this is 10. Okay, 10 is small till how much? 10 is small till the value 7. For every element, 10 is the smallest. So there is no element this side, there is no element this side. So suppose I have 1, 2, 3, 4, 5, 6 and 7. So what I can do is, I can write that 10 is smallest. 10 is smallest as of now. Because earlier, what I would do is I would simply initialize everything with 0. I found a value greater than 10, I would fill it. Okay. Next, what we would do is just do the dry run with me. For the value 20, I can go till how far? I can go till how far? I can go till here. And I can go till here. So I got an eligible candidate for size 3. I got an eligible candidate for size 3. So for size 3, I would remove this and I would write 20 here. Okay. Then for 30, I can go till this side. Okay. And I can go till this side. So we got an eligible candidate for size 2. So we would just write here 30 because this is greater than 0. So we would just write it. Okay. Fine. Okay. We are now, this is done. Now we would be considering this. So for 50, how far I can go? I can only go till this point because 10 is smaller and I can only go till this point. So for the value 1, I can see that it is the candidate. Okay. So I would just remove this and append 50 here. Okay. Fine enough. Okay. Okay. Now we would consider this element. For 10, I can go till how far? I can go till this side also, till this side. There is no limit only. So I would do the things which are not in limit, I would take the whole size. So 10 is equal, so I won't update it. Now coming to 70. 70 I can go till how far? 30 is less, 10 is less. So I can go far this side. So 70 is there. So what I would write is 70 is there for a candidate of size 10. Okay. Then we would again come here. Okay. 30. How far I can go? I can only go till this side. Okay. How many elements? 2 elements. For the elements 2, I got a value of 30. 30 would be there. So if you can see, after all this iteration, I am getting the values what? For first value, I am getting 70. For the second value, I am getting 30. For the third value, I am getting 20. And for the 30th value, I am getting 10. Okay. Okay, fine enough. Now there are still values that are not updated and are initial and still left over with 0 only. What would we do in that case? Okay, quickly tell me what should we do? Okay, I'm giving you one hint. Okay, I would give you a hint after 15 seconds. Think for 15 seconds, then I would give you an hint. Okay, no problem. Okay, fine enough. Okay, so we would wait for, okay, Swami, most welcome Swami. श्रीवास्तन सर एक्स्ट्रा एक्सप्लेन करते हैं, डोंट कॉल मी सर, भाई कहो, सिद्धार्थ कहो, साइड कहो, एनफ है. Okay, thanks a lot Srivastav. Okay, can you tell me what should we do in this case? Okay, as 30 seconds have passed, I would give you a hint. Hint is that, okay, for the value of size 10, what was the minimum? The minimum was the minimum in the whole array. Okay, yahi tha na? So for the size less than 7, the value kya hoga? The value would be greater, the value would be small, or the value would be equal. Think in this direction and you would be able to find out a solution. First tell me. Okay, this is the hint. I would be waiting for the next 30 seconds. So just tell me, what would be the value? Greater, smaller, or equal? Just tell me that. Just think it that way. What would be the value? If for the 7th value, for the whole size length value, it is the minimum. So for 6th value, what is the value? First tell me. Okay, understanding this is absolutely simple, but might be hard if you are not with practice. Okay, I would tell you. For the whole array, I am taking out the minimum. So if I decrease the size, then the value can be that or less, but it can't be, or the value can be that or greater. It can't be less. Why? Because what can be worse than taking the minimum in the array? What can be the worst answer? इससे worst कुछ है ही नहीं. There is nothing worse than this. Okay, मैंने क्या बोला कि जब लेंथ 7 का जब लिया तो सबसे मिनिमम आंसर हो गया. तो अगर उससे छोटे वैल्यू का लेंगे तो उससे बेटर या इसके जैसा ही आंसर आएगा. इससे नीचे तो हम लोग जा नहीं सकते. That is the thing, that should be clear. Okay, fine enough. Now what we would do to do this is that we would take out the value from this, because we are not getting eligible candidates and we know that the value can't be less than that. So what we would do is, if the value is equals to 0, we would take the maximum of it. The maximum would become 10. Now we would update it with 10. Now this is again 0. This would again become updated to 10, and this would again be updated to 10. And this is how we are filling these values. Quickly tell me if this is clear or not, because I would be moving to the next part now. Okay, quickly tell me if this is clear or not. There are 5 live viewers at the moment, so please do let me know. Okay, by the way, people are downvoting me today. What happened? Am I explaining too bad? Okay, now what are the things we need to find out? The next nearest smaller element. Okay, nearest smaller on both sides. Okay, nearest smaller on both sides. This is the first thing. Then what we are doing is, we are creating an extra array which are initialized with 0, and then we are filling the values. The values which are not getting updated, we are updated with the values moving from the back itself. Okay, thanks a lot Anonymous, thanks a lot Swami. Okay, it means a lot. Okay, now we need to find the nearest smaller element on both sides. Okay, now there comes a prerequisite to just combat this. Okay, combating this comes a prerequisite. What is the prerequisite? The prerequisites are nearest next greater element. Now it becomes the prerequisite. Okay, now if you know next greater element, then I consider saying you what you can do is, at this point, if you don't know next greater element, you should first try to solving this by how you come to this element. Then what you need to do is you need to go far, how far I can go. Then suppose I am at this 50, so I would see that how far I can go. I can only go far till this point and this point. So I would simply take a loop on the right side and on the left side by using a simple loop. Okay, so there is a better version, and this would take, for each element we would do 2 loops moving this side and this side. So we would be doing n operations for each element. So for n elements we would be doing n square operation, and this operation is again taking big O of n. So your solution would be having big O of n square solution, as the length of the number of elements is still 10 to the power 5. 10 to the power 5 to the power 2 is equal to 10 to the power 10, which is greater than 10 to the power 8. So this would give you a TLE. Now what is the optimized version of that? The optimization comes in the part where we are doing an n square approach. जहाँ पर ज़्यादा किया वहीं पर तो कम करेंगे ना. The point where we are doing more task, we would be trying to minimize that task, because On can be passed and these all can be passed. So we would be trying to do this n square 2n. How to do this n square 2n? You need to learn a technique known as next greater element. This is a very famous question. You should be knowing that if you are doing competitive programming, if you are preparing for interviews, anything you would be having, you need to know this concept. This concept is absolutely very important. This concept was used in around 4 to 5 months earlier. This concept was used in Codeforce's concept, and this concept was used in recent contest of CodeChef, either lunchtime or cook-off. Just confirm it. It was the 4th question, okay, of Div 2. Okay, explaining good, but little hard to grasp the problem, I guess. Yeah, it is. To be honest, this is a hard level problem, and the quantity of the people who know these all problems are very less. People are mostly intermediate or people who do easy problems. Hard level problems require a lot of patience and a lot of practice. So the number of the quantities of that kind of people is absolutely very less. Okay, so now to fill this so look at this value, we should be learning about a technique known as next greater element. So after if you are seeing with the recording, pause it at this point and then learn it and again come back. Okay, now I assume that you have already thought about this. Now after being thought about this, what we would do is we would just make it a little more. So I would just do the dry run, how we would find the next smaller element. Okay, finding out the next smaller element is absolutely very easy. I would tell you how. First we need to develop a stack. Okay, initialize a stack. Then the first value is 10. Okay, the first value is 10. If the stack is empty, we would simply push it. Okay, after we have pushed, the second value is 10. So we would push this again. Okay, if this is greater, we would push it. If this is greater than the top element, we would push it. 30 is greater than the top element, so we would push it. Okay, 50 is greater than the top element, we would push it. Now 10 comes. 10 is smaller than 50, so we would say that 50's next smaller element is 10 on the right hand side. Okay, now again 10 is here, 10 is here, so we would remove 50, and then we can see 30 is again greater than 10, so we would again say 30's next smaller element is 10. Okay, simply this idea is absolutely very simple but very good to know. Then again we have a 30, so we would again tell that see 30. Okay, we don't have an again 30, this 30 needs to be removed. Okay, so for again 10, the value 10 is for a value 20, the value 10 is smaller. Okay, so we would say 20's next smaller element is 10 itself, and we would remove this 20. Now this value is greater or equal, so we would simply insert this value. Next we have 70, we would again insert it. Next we have 30, which is less than the top value. till the value is less than top value. So we would just what do, 70's next smaller element is 30. Okay, so we would remove that. Next we are again inputting 30. Okay, for the numbers which are there at the end, after all the iteration, we would say that there is no next smaller element on the right hand side. So if there is no next smaller element on the right hand side, what we would do is, this is 0, this is 1, this is 2, this is 3, this is 4, this is 4, this is 5, this is 6. Okay, 0, 1, 2, 3, 4, 5 and 6 to be more precise. Okay, so what we would do is, for the right hand side we would also take up a value 10. For the elements which are not having the next smaller element, we would say that your next smaller element lies in A of 7. We would hypothetically tell it next smaller element of this is A.7 and 10 is A.7. Now how would we perform it? Now I would tell you. Suppose for the value 30. Okay, for the value 30. So 30 is next smaller, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So 30's next smaller element is this one, and 30's next smaller element on the left hand side is this one. So what we would do is, 4 minus 1 is equals to 3. 3 is not our answer, 2 is our answer. So we would just subtract 1. So right value, right eye minus left eye, okay, right eye minus left eye minus 1. This would give me the length. Okay, this would give me the length. Fair enough. Okay, let me read the values and let me know if this is clear or not. Now, talking about taking out the values for the left hand side, what we would do is, we would simply start iterating from the back. For loop, we need to just change the for loop condition that we would starting from n-1 to 0. This is it. And we would take out, and instead of storing the values, what we can do is, we can store the indexes so that we know the next index. Okay, fine enough. Okay, what can I learn? What can I learn from this question? Okay, yeah, will this help to solve similar problem? Will this help me to solve similar problems? Yeah, we would be talking, we every day talk about similar problems, and what other problems you can solve, we talk about that at the end of this explanation. Because if I start talking about the next all question, we can't do that. Okay, so I would be giving you at least a one question, and the rest of the question I provide in LinkedIn. Okay, so please bear with me and I would be more than happy to explain you. So what is the idea? That we would be using a stack to take out the next smaller element on the right hand side, then we would flip the condition of the for loop and we would take out the next smaller element on the right hand side. Okay, and then what we would do, what is the length? Ri minus li minus 1, it would give me the length, and we would update it with 0 value, then we would update it. At the end, what would be the value? The values which are not there, we would start from the back. Why? Because the value from the back can't be less. Okay, I talked about that. Isse bura kya hi ho sakta, just remember that. Okay, now let's start with the iteration. The iteration is absolutely the implementation is absolutely very simple. So we would initialize the stack, we would initialize the left array of n plus 1, we would initialize the right array of left plus 1. Okay, you can do it with n because you need to handle that case 0 and n minus 1, you can do that, but I did it with n plus 1 because the editorial solution was more elegant enough. What I did was, I initialized every value with minus 1 and n. What you can do also is that the value which are remaining, you can fill it with n for the right hand side. Okay, for the right hand side, because there is no element on the right hand side, so we are putting it n. For the left hand side, the same thing would happen and we would put it minus 1. This is what we are doing. So instead of checking at the last the values which are not updated, we would update it. Instead of that, we are initializing in the top only. Okay, initializing in the top. And then what we are doing, we are starting from the 0. If the stack is not empty, we would simply keep popping while the top element is greater than the current element, and we would say that this is the value. While the stack is not empty, we would say that, and at the end we would just simply push it. Okay, and at the end, whatever value is remaining, we would simply remove it from the stack. Why? Because we need it for the iteration on the right hand side. Okay, then we would start iterating from the right hand side. To take out the values on the right hand side, we would start from the back. That is why we start from the back until greater than is equal to 0. Whatever the value is remaining, we would simply pop it, but we can leave it. Why? Because we don't need the stack again. So you can leave the values unchanged. If you want, you can do that. Okay, that is a kind of extra work that need not to be done. Okay, now we are initializing answer minus 1. We are initializing every with 0. We have what we did in the first, every with 0. And then what we are doing is right minus left minus 1. We have talked about this formula. Then at the end we are talking about the length. We are updating. Suppose this was 0, this was, then this became 10, then this became 100. We want the maximum value, so we are taking out the 0 and we are keeping out the value. So we are keeping out the values. Okay, then what we are doing is we are starting from the back. Okay, starting from the back, whatever there are values, we are taking out the maximum, because last से बुरा क्या ही हो सकता है. Okay, now rest plus 1. Okay, now this is how we can do is I minus 1, that I, and then we are returning it. Now for the next moment of time, let me know if understood or not. Okay, understood or not, let me know. Okay, just let me know in the chat. Okay, now the next thing is that what are the things that you are learning. The first thing is that we have talked about next greater element. So the people who don't know learned that. The people who know that were able to see a application of that. Now the people who knew next greater element but were not able to apply to this question, then they need practice. They need practice means they need some questions. They need some questions means I need to provide this question. So the question you can solve is largest area in a histogram. Okay, solve this question. And what are the other question? Okay, what are the other question? Other questions you need to ask me on LinkedIn, because providing all the question is kind of very difficult. Okay, so ask me on LinkedIn. My username is Siddharth Hazra. Just search me there. Okay, I would be there. Okay, I'm from Netaji Subhash Engineering College. That is a identity of mine. Okay, just send me a request. Ask me that Siddharth, for this day of POD, this was the topic. Tell me the topic also, that I don't need to check, and ask me that what are the other problems I can explore by using this technique. Okay, and by doing this, you are not paying anything. I'm doing it for free, just for free. Okay, and you would be improving. Okay, so that's all for today. I hope you have understood it. I would still wait for the next 1 minute to see if there are any doubts or not. If there aren't any doubts, I would be turning this session off. Okay, and if you are seeing the recording of this video, let me know. Okay, let me know if you have any doubts in the comment section by tagging me, so that I get a notification, or else you can ask me on LinkedIn. Okay, बस इतना ही था सफर हमारा. Okay. Thanks a lot. I would be coming again back tomorrow to explain today's POD. Okay. By the way, there is one more thing. Only 30 seconds remain. I would be explaining that in 30 seconds. There is one more thing, is that there is the course on data structures with C++. This is a live course where I am the sole mentor of this course. This course is suited for the beginners as well as for the intermediates who want to master data structures. And with this course, you would be getting a complimentary course of the C++ foundation, first thing. Second thing, and third thing is that there is an offer going on of 50%. If you want to avail that offer, just go to the link page and you would be getting it. Okay, you are most welcome. Sir, hacking के लिए hardcore coding skill चाहिए था, या hacking के लिए तो लगेगा. Okay, most welcome Swami. So that's all for today. Okay, thanks a lot Swami, thanks a lot Priyanka, Swami, and then Srivastan and Satyam Gupta. Thanks a lot for attending this session. Anonymous, thanks a lot. So now I would be turning this session off. Meet you tomorrow at the same time.